Good morning, friends. Now, after completing our theory of radiation, we are going to solve a numerical on radiation. So, this numerical is asked in GTU May 2014. So, determine heat loss rate by radiation. So, we have to find the Q by radiation from a seat tube or outside diameter 70 mm. So a tube having outside diameter 70 mm and 3 meter long, and the cylinder is at a temperature of 2 to 7 degree centigrade. So for tube we are using D1 70 mm, and here we always use meter for length and Kelvin for the temperature. So diameter is 70 mm, so we can write 0.07 meter, dividing it by 1000, and we get now the length is 3 meters, so we are just putting 3 meter here. T1 is 227, so by adding 273 in Celsius we get Kelvin 500, and from this we can calculate the area of that cylinder. A1 is pi d1L, or we can write 2 pi r into length. So we are getting area 9.659 meters square, and the tube is located within a square brick of 0.3 meter side. So the brick is square and the side of that brick is 0.3 meter, and the temperature is given 27 degrees, and emissivity of steel is given and emissivity of brick is given. Now for brick, the side length is given, it is 0.3 meter, so we can calculate area from that, and as the brick has 4 sides, so this will be length, and this is the square, and the side of that is A. So A into A into A into A means 4A, or A means if we consider the circumference of that, so we can write A plus A plus A plus A, means it is 4A into length. So this area works as a surface through which the heat is transferred through radiation. So 4A into L is the equation for that, and area, so we are putting A, and it is 0.3, and length is 3 meter, it is given. So you'll get the area for brick is 3.6 meter square. Emissivity is given, the temperature of that brick is 27 degrees centigrade plus 273, so we get 300 Kelvin. Now heat loss, we know the equation we already discussed for the cylindrical surface. Heat transfer is A1 sigma T1 raised to 4 minus T2 raised to 4 upon 1 upon epsilon 1 plus A1 upon A2 1 upon epsilon 2 minus 1. So we know the area for cylinder and area for brick. This is the Stefan Boltzmann constant. We need to remember the value of that. It is 5.67 into 10 raised to minus 8. T1 we know it is 500, T2 is a 300, it is in Kelvin, and emissivity for cylinder and emissivity for brick we know, so put in this equation. So by solving this equation we get heat loss is 1591.5 watt. Thank you.